Okay, we're getting into chapter 1.6, which is also a one-day chapter or one-day section. I will warn you now that the test for this whole chapter is next Friday. So yes, you are preparing for a quiz tomorrow, but as we get into next week and we start learning the rest of this chapter here, you might want to make sure you start looking back at all your notes, because the time to take that test that you cannot make up, that 50% portion of your grade, is coming up fast. So again, make sure you are planning on any kind of tutoring days, anything like that, to get ready for that test coming up next week. Other than that, we're talking about multiplying and dividing real numbers, and I can tell you that the lesson material on this is pretty simple. The key idea is that you are not, N-O-T, going to change the way that you multiply or divide, but you will learn how to incorporate the negative signs into your answer. So let's get into it, and let me just show you in a Sesame Street way. This time I did not steal the money out of my wife's piggy bank. I simply found the chips that I was supposed to have yesterday. So 3 times 2, as you learned a long time ago, means you make a rectangle with a row length of 3 and a column length of 2. I think I might even have that backwards, but bottom line is you make a 3 by 2 figure and you count what's there. So of course you have 3 things here, which makes your 3 times 2 6. Before we get into the actual multiplications with negatives, though, I want to explain what the negative sign means. So again, with that model that I just gave you, that is what multiplication works like. But we are going to look at some models for multiplication with negatives, so you can understand exactly why you don't have to change your multiplication or division. Again, everything that applies in multiplication applies in division, so we're going to use multiplication as our base idea to kind of understand what's going on. But I want to first explain what the negative sign means, and the negative sign literally means opposite of. So because of that, we model a positive 3 like this, with 3 positive, yellow being positive, chips. And we model a negative 3 being opposite as 3 red chips. So again, 3 positive chips represents a positive 3. 3 negative chips just means take all those chips and turn them over, which means flip them over, because that is the opposite of your positive 3. Again, notice that the amount has not changed, but the negative just tells us to flip the sign on the amount. So again, what the negative sign does is it means flip it over. If it's positive, make it negative. If it's negative, make it positive, etc. So how do we model the problem of negative 4 times 2? Well, first what we do is we do 4 times 2, because the amount, as I just said, does not change. So we will make a 4 by 2 rectangle, which looks like this, kind of like this, sorry. There's a lot of chips in this one. And then what we do is we count the negatives. In other words, remember, the negative means opposite of. It tells us to flip. And so there's 1 negative in this whole problem, which means we're going to take everything and flip everything 1 time, which means that when you do 4 times 2, you get 8. But negative 4 times 2 actually ends up being a negative 8, which is why, again, 4 times 2 is 8, but the 1 negative makes that 8 negative because we flip it over. Alright? The one that you need to be looking out for is this one. And it is the one that has 2 negatives or more than 1 negative, because again, anytime you flip an answer over, it's going to be negative. But 3 times 4, again, it means make a 3 by 4 rectangle. 1, 2, 3 by 1, 2, 3, 4. We fill this thing out. We get this shape all the way completed, and of course you understand that your answer is going to be 12, but it's what we do next that tells us why our answer is the way it is. So we've got our 3 by 4 rectangle, and we've got 2 negatives, and what I need you to understand is that in this situation, your 1, 2 negatives tells me I'm going to flip everything twice. So that would be once, and guess what happens when we flip it back over is it turns back positive. So if you imagine taking all these and flipping them twice, that is why your answer is not a negative 12, it is a positive 12. 1 negative would make it negative 12, but the second negative makes all your negatives back into positive, because you flipped it over once for the first one, flipped it over second for your next one, and that is why your answer would be a positive 12. Again, 3 times 4 is 12. The multiplication stays the same, but the 2 negatives mean flip it over 2 times, which means make it negative, then make it positive, so your answer would be a positive 12. The overall idea is this. after all that stuff. Multiply or divide while ignoring the signs first to get your number. Count the negatives to see if the number is positive or negative, and then go from there. If you look at the relationship, one negative means flip it once is going to be negative. Two negatives means starting here and we flip it twice. That's one flip. That's two flips. Is positive. If we had something with three negatives, that would be 1, 2, 3. Of course, that is negative. If we had something with four negatives, you can probably assume one flip is negative, 2 makes positive, 3 is negative, 4 makes positive, and you see that this pattern just continues over and over. Now you do want to make the connection that these numbers here are odd. In other words, every odd number flips me, I'm going to be on the opposite side of positive. Every even flip means that I'm offsetting my negative to go there. So if there were 8 negatives, it would probably be positive because you're going to flip it over an even number of times. If there were 31 negatives, then that would be negative because that's an odd number of negatives, and that's what you kind of got to worry about or to think about whenever you're working those things out. The overall idea for, or the big idea for multiplying negatives is just making sure that after you multiply or divide to get your number, that you count your negatives carefully and make sure you put the proper sign on it. One more thing before we move on is that I need to be sure we understand how to multiply and divide fractions with a couple of examples. So your set of notes for multiplying fractions is here. You might want to write that if you don't remember it. It's simply top times top, bottom times bottom. It's a very simple concept as we do that. If you were asked to multiply this, first off you would multiply top to top, bottom to bottom. There is only one negative in this problem, which means that our answer is negative. Remember, we just learned that. One negative means it's negative. 4 times 3 gives me a 12 up top. 7 times 8 gives me a 56 on the bottom. Both of these are divisible by 2. That makes it negative 6 over 28. Both of those are divisible by 2, which makes it a negative 3 over 14. As my answer, that is reduced all the way through. You will notice that I did this without a calculator, which is what you will learn to do as you continue to think your way through these problems. But again, you have to start thinking your way through these problems to get to that level of work. But again, first thing we do is we counted our negative, knew it was negative because there was just one. We did our top to top, bottom to bottom, got our answer, and reduced it. You could also type this into your calculator and do math, enter, enter, and get the same thing. But again, I would rather show you that it's possible to do these multiplications without a calculator. Here we are multiplying two fractions again, so the first thing I would do is recognize that there are 2 negatives. And remember, 2 negatives means you flip it right back over, so our answer should be a positive. We don't need to put it. Top to top on the fraction gives me a 2 on top, a 15 on the bottom, and those two don't go into each other, so therefore you end up with 2 over 15. So there are some fractions on your quiz tomorrow. There's probably some fractions on your test. I'm not really sure. I haven't looked at it in a couple weeks, but for the most part you can assume again that fractions are going to be existing because we need to get you ready for those kinds of numbers. To divide fractions, again looking at notes on dividing fractions, there's only one small shift, and your notes for division is this. Now you might want to write what those 3 things mean, but keep, change, flip means rewrite the first fraction, change division into multiplication, and then flip the second fraction. The general idea is that we don't know how to actually divide fractions, but we do know how to multiply fractions. And so what we do is we turn this division problem into a multiplication problem, which of course you know is a top times top, bottom times bottom problem. So whenever you see a division sign, we cannot do it. So what we do is we keep the first fraction the same, we change this to a multiplication, and we flip this over to be 7 over 2. Now that it's in multiplication form, we follow our instincts and get our answer. Well, looking at this, there's 1 negative, which again, it's odd. That means that's going to be negative. 4 times 7 is 28. 3 times 2 is 6. Both of these are divisible by 2, so it's negative 14 over 3 as our final answer there. Not a hard process, but again, you've got to make sure you remember how to divide fractions also on the top of your head, just in case you have to do that at some point, which you never know when that'll pop up. Here you've got 2 negatives, which means it's going to be positive. Again, we don't need to write that, but it's a division problem, so we're not used to it. So what we're going to do is write it as negative 4 ninths times negative 2/3. Again, I think I counted my negatives too fast, but it's okay. Again, once we get ready to work this out, 2 negatives makes it positive. 4 times 2 turns into 8. 9 times 3 turns into 27. I can't think of any number that goes into both. That should be my final answer. And once again, in terms of your calculator programming, you might even want to type these two things in just to make sure you can get those answers, because you want to be able to do them without a calculator, but it also helps to be able to do them without a calculator. So be sure to keep these things in mind for your number sense. Also be sure to practice them, as I said, on your calculator, because both ways are important. Good luck, and make sure you start reviewing for that quiz tomorrow. Some of you did not do as well as you could have last week, and you need to offset that for that grade, because nobody has made up that quiz yet, and I'm getting the idea that you probably are not going to utilize that like you should. So the best way to make sure you don't get a bad grade is to make sure that you go ahead and get a good quiz grade, so you don't have to make it up and then get stuck with a grade you don't want. So good luck.